Start with our new case study. This is the select query. Select e dot first name, e dot last name, e dot hire date from employees and comma departments D1. So this is a join operation between employees and a departments table where e dot employee ID in, where there is a subquery. Select manager from departments T2 where department ID is equal to 10, and then there is a join operation e dot department ID is equal to d1 dot department ID and d dot location ID is equal to 1700, and e dot hire date is greater than 30th Jan 2000. So the output of this query is a single row. So let's analyze what the fundamental approach for SQL tuning is. So the fundamental approach for SQL tuning states that we start with such a column in the where part of the clause which has got too many distinct values. Okay, let's see how we want this query to be executed and how Oracle has actually executed this query is one and the same or not. Okay, so in this case, if we go with the fundamental approach, there are only three columns which we can start with. So the first column, first where clause part is e dot employee ID in, okay, and d dot location ID is equal to 1700, and then e dot hire date is greater than 30th Jan. We can't start with this join operation first. Instead of that, we have to start with either of these three where clause predicates. So let's see if we start with e dot hire date is greater than 30th Jan. So e dot hire date greater than 30th Jan 2000 is going to qualify for too many rows, right? So this is not a very good column to start with. Next column is d dot location ID is equal to 1700. So in departments table, location ID is again not a good column. So d dot location ID is going to again qualify for more number of rows. So the only column left is e dot employee ID, right? So in order to access the values of e dot employee ID, so now employee ID in an employees table is a primary key. So any output which comes to this in part of the clause will always be unique and is going to always expect one row for whichever value that is passed inside this subquery. So in order to get the value of e dot employee ID, we need to execute this subquery first, right? So this subquery, if we try to analyze, so it is doing a select manager ID from departments T2. Okay, so it is accessing departments table where department ID is equal to 10. Now in departments table, department ID is a unique key. So the output of this query again will always be a single row. So that means one row will be executed from the subquery and then the value will be given to the e dot employee ID. So as per our analysis, we have to make sure that Oracle will first execute this subquery, then it does then it tries to do employee ID in this part of the where clause, and then it should go for a join operation. Okay, so this is the way the Oracle should execute this query. So now let's see whether Oracle has actually taken this execution plan. So looking at the execution plan, what Oracle has taken. So this is the execution plan. And if you create a parent-child relationship in this execution plan, so fourth operator will execute first. Okay, so let's see what fourth operator is. So fourth operator, if you look at the predicate information for the fourth operator, it says access d1 dot location ID is equal to 1700, right? So before that, if you see the row column, right? So row column is expecting, each operation is expecting some rows which are more than one, right? If this, the output of this query is only a single row, so in order to execute this single row, what I see is that there are so many rows which the each and every operation is expecting. So this is again definitely not a good thing, because the output is one row but each operation is expecting more number of rows. So this is possible only if you don't have a good clause in the where part, but we already have an employee ID which always expects one row. So why is Oracle expecting so many rows out of each operation? Okay, there is something definitely wrong going on here. So let's look at the predicate information. So as like I said earlier, looking at this parent-child relationship, fourth operation will execute first. So fourth operation is nothing but you're accessing the department's D1 based on location ID is equal to 1700, right? So this clearly says that instead of accessing e dot employee ID, it is first accessing d dot location ID is equal to 1700. So in again, like I said earlier, in the departments table, location ID is not at all a good column. Okay, so because it is expecting more number of rows out of this join operation. If this had been a unique column, what I meant to say is that if location ID would have been a primary key or a unique key or such a column which would have given less rows for 1700, then it would have been good. But in this case, d dot location ID is equal to 17 is expecting 21 rows out of this operation, right? So yeah, so fourth operation is your d dot location ID is equal to 1700. Then after 4, 3 will execute. So 3 is nothing but table access by index row ID on departments table. So that will try to access department ID of D1. So this department ID it will try to access, because when it scans the fourth operation, that is index range scan on location ID is equal to 1700, it has only scanned location ID. But for departments D1, I also need to scan department ID as well for further operations. So that's why there is a table access by index row ID, which is the third operation. So now it has scanned D1 dot department ID as well. So again, when you create a parent-child relationship, so next operation after this will be the fifth operation. So now fifth operation is nothing but table access full on your employees table. So if you see the fifth operation, it is doing a table access full on the employees table, and then it is filtering out hire date greater than 30th Jan 2000. So this means that after filtering out d1 dot location is equal to 1700 and then going with the join operation over here, it is further accessing the employees table and then try to filter out the hire date which is greater than 20,000. So after this, it does a hash join, which is the second operation. Okay, and if you see the second operation, it is doing the join part. So that means this part of the clause, right? So how the Oracle has executed this step? So it has first accessed the d dot location ID is equal to 1700. Then it has accessed the e dot hire date greater than 30th Jan, and then it did a join operation between these two, and later seventh operation will execute, then sixth operation. So seventh operation is nothing but executing this subquery and then accessing the e dot employee ID after all the join operation and all the filtering is done. Okay, so this is definitely a very lengthy operation which Oracle has taken. So in order to make this query better, so before moving that, let's see the statistics, right? So we were saying that if you see the employee ID column here, so employee ID column is having 107 distinct values, right? And is having 107 rows as well. So starting with the employee ID will always be the best way to start with, right? And if you see the location ID of the departments table, it is having 7 distinct values and the total number of rows is 27, right? So that is why the location ID is may or may not be a good column to start with. So that is the reason why we should start with e.employee ID, right? And then go for a join operation with the department table, and then this rest too will go out as part of your filter operation. Okay, so in order to make this work, we have to introduce some hints. So now let's see how we should execute this query, or what is the solution for this query. So whenever you see such a query which has got a subquery, we should execute such a subquery first, provided that the outer column for this subquery is having more number of distinct values. For example, in this case, e.employee ID is having too many distinct values. So that's why this subquery we should always execute first. Then e.employee should be accessed. After that, the result should go with the join operation, and then we'll filter out from the join operation whatever rows we have got back from these two output. So we will filter out d dot location ID is equal to 1700, and then we'll filter out e dot hire date greater than 30th Jan 2000. Okay, so how we can achieve this? So in order to achieve this, we will pass just a small hint that is called as leading d2. Okay, so d2 is nothing but the table alias name. So this is the department's table, and for that we have a d2 as the alias. So this alias will be passed as a leading hint. So that's why this subquery will execute first, and then e.employee ID should be accessed. So let's see whether the Oracle has actually executed the expected plan. So looking at this is the execution plan after passing the leading hint of D2. So if you again create a parent-child relationship for this operations and or the execution plan, fourth operation will execute first and then third operation will execute. So let's see what is the fourth operation. So fourth operation is nothing but accessing the department ID is equal to 10, right? So what does this mean? So it is accessing department ID is equal to 10. That means it is executing the subquery first, which we wanted. So after this subquery is executed, we have to make sure that e.employee ID is accessed next. So once fourth operation is done, third operation will execute because 3 is the parent of 4. So what is the third operation? So third operation is nothing but filter of manager ID is not null. So why there is a table access by index row ID for the third operation is because it has accessed the department ID is equal to 10, but for that department ID is equal to 10, it has not accessed the manager ID, right? So that is the reason why you see a third operation table access by index row ID, so that it can fetch the manager ID information. So after that, sixth operation will execute and then fifth will execute. So what is the sixth operation? Sixth operation is nothing but accessing the employee ID is equal to manager ID. So that means, so this part of the clause, e.employee ID in. So this is getting executed, right? So this is what we wanted. So sixth operation is nothing but accessing your employee ID for that respective manager ID. So this part of the clause is executed here. Now at again fifth, if you see, after sixth, fifth operation will execute. So what is the fifth operation? It is filtering e.hided greater than 30,000. So after this query is executed, this part of the clause is executed, it will try from this employees, it will try to filter out e.hided greater than 30th Jan 2000. So if from this row, that if the employer hire rate is greater than 30th Jan 2000, that row will be retained. If not, that row will be discarded. All right. So after that, eighth operation will execute and then the seventh operation will execute. So what is the eighth operation? So eighth operation is nothing but e dot department ID is equal to d1 dot department ID. So this is your join operation. So this is exactly what we wanted. So looking at this execution plan, this is the best execution plan which it is supposed to be running, and this is what we wanted Oracle to execute, right? So to summarize, this execution plan has first ran this subquery, then it has ran the e.employee ID because this is the primary key. After that, from this row, whatever the output of this part of the clause was, from that row e.hided was filtered out, and then it was given for the join operation. And later d1.location ID is equal to 1700 was filtered out as part of the seventh operation. So do you see a filter predicate here? Location ID is equal to 1700, right? So this is how you should execute, look or tune a query which has got a subquery. You start with the subquery first, which has got an outer column with too many distinct values, rather than going with such a column that is d.location is equal to 1700, which has got very less number of distinct values, right? So if you want to further confirm that the investigation is correct or not, so you just run this inner subquery, select manager ID from department A2 where department ID is equal to 10. So the output is only one row with manager ID is equal to 200, right? Then you can fire this query, select count of star from employees where employee ID in 200. So this is going to give you one row. Okay. So we are running these two queries to validate that the output of this query is a single row and the output of this clause e.employee ID in is also a single row. So those two things we have validated. So that's why we have a one row here. So if you want to further analyze, if you accessed e.location is equal to 1700 first, how many rows it is going to give you back? It is going to give you 21 rows, right? So overall department is having 27 rows. So out of 27, it is you are accessing 21 rows. So definitely this is not a good column to start with. So the ideal way is to start with the subquery and then to start with the e.employee ID and then go for the join operation. Okay. So this is how you can tune a query which has got a subquery within it. So with that said, we'll conclude the case study for today, and I wish you a very wonderful tuning experience.